In part 2, we will explain the second column. So we'll make this just a little bit bigger. So we're going to look at the first problem. And what we talked about in class was go ahead and if it has a subtraction sign, put it in parentheses. If it has addition, put it in parentheses. If it has addition, subtraction. If it's on top or on the bottom of a fraction, it has addition or subtraction. That is not the same as being a factor. Factor means multiplication. So you can't just cross off 4. You can't just unsubtract 4. You have to actually cancel things out. So you can't do anything with them right now because the top and the bottoms, nothing matches. So what you need to look at is what's in common with 3a and 6. And we find out that they're each a multiple of 3. So if I factor out the 3, 3 times a is 3a, and then 3 times 2 is 6. So if we were to distribute it back out, we say 3a and 3 times 2 is 6. So this is factored for the bottom. So we're going to rewrite the first fraction as a minus 4 as a quantity. And then at the bottom we have 3 times a plus 2 as a quantity. So the only way I can cancel out the top or the bottom with the a's, it has to be a minus 4 or a plus 2. We can't do anything else. And then we have times. And if I look at 2a and 8, I can factor out a 2. So if I divide 2a by 2, I get a. And if I divide 8 by 2, I get 4. So the top is still a plus 6. And the bottom is 2 times a minus 4. And then in multiplication, basically multiply the tops together and the bottoms together. So that means anything on top can cancel out with anything on the bottom. And this whole quantity here, a minus 4, is the same as this quantity here, a minus 4. So then I end up with a plus 2 and a plus 6. Well, those aren't the same, so we can't do anything with them. So we're just going to write our answer. On the top, I have a plus 6. And on the bottom, I have, well, if you want to put it in parentheses, you can. We have an a plus 2, but we also have a 3 times 2. And 3 times 2 is 6. So this will be our final answer. Not everything cancels all the time, so it's okay if we have an a in the top and bottom if it's addition or subtraction. In the second problem, we have division, and we talked earlier about what happens to division. So we're going to change division to times, and then we're going to flip the second fraction. So we are going to write 2m plus 10 over 4k minus 20. This changes to times, and then we flip the second fraction. So I have k minus 5 on top now, and m plus 5 on bottom. And we talked about the fact that this has a plus sign, so it's a quantity. This has a minus sign, so it's a quantity. This has minus. This has plus. If it's on the top or the bottom of a fraction, it has plus or it has minus. You have to take it as a whole quantity. You can't just cancel out. So it can't cancel 5 from k minus 5 and m plus 5. It's not the same thing as dividing them out. So right now, I can't really do anything. But if I look at the top, I have 2m plus 10, and they can both be divided by 2. So I'm going to write the first, so these are equal. So I'm going to write the first fraction as 2 times, and if I take 2m divided by 2, I get m plus, and then 10 divided by 2 is 5 over. And then on the bottom, I can divide both 4 and 20 by 4. So I'm going to take 4. If I divide out that 4, I just get k. And if I divide 20 by 4, I get a negative 5. So if I were to multiply it back out, I'd distribute 4 times k is 4k, 4 times negative 5 is negative 20. So I can always check to make sure if I distribute back out, do I get back the original quantity. And then the second fraction just stays k minus 5 over m plus 5. And as we said at the top, if we just make this a big line and we multiply the tops and multiply the bottoms, because that's what we do when we multiply, then I can cancel out this whole quantity k minus 5 and this whole quantity k minus 5. And if you think of it, What would it be if k were 10? Then up here, 10 minus 5 would be 5. And then down here, 10 minus 5 would be 5. And then they would cancel each other out. So it should make sense that I can cancel that whole quantity. Then I can look at, okay, well I have m plus 5 is the same here and here. So I end up with just 2 over 4. And if I simplify 2 over 4, I get 1/2. So this would be the answer for the second one. Notice that this time all the letters canceled out, and the top one they didn't. That's going to happen. You'll have one or the other. Sometimes you'll have letters, and sometimes you won't. On the third problem, we have addition, and we have our favorite thing to do is find a common denominator. So we look at 7 and 2. Well, we don't really have any factors. So 7 times 2 is 14. So I need to multiply this by 2 to get 14, top and bottom. And over here, I need to multiply 2 by 7. And that means I have to multiply this piece on top by 7. And what we said in class and what we've said here is that if I have a quantity on top of a fraction bar that has a minus, it has to be a quantity. You have to treat it as one thing. So you have to put it in parentheses because the 7 isn't just times the 4 and it's not just times the 7. So depending on where people put the 7, they might be at 7x or they might get minus 28. But the fact is the whole top has to be multiplied by 7. So that means 7x and 28. You have to have both. So let's look at the x's. We have x squared and we have x. We said before we have to have the bigger one because we can't divide. So this side needs an x because I need x times x to be x squared, which means the top needs an x as well. And then I'm just going to multiply. So 2x times 6x. 2 times 6 is 12. X times x is x squared over, and then I do the bottom. 2 times 7 is 14. X times x is x squared. And yes, I see that it's x squared, and yes, I could cancel them out, but the whole point of this problem is to add the two fractions together. So if I cancel out the x squared, I no longer have a common denominator. So keep that in mind as you're working through. Yep, I can cancel out the x squareds, but that is not the point of this exercise. It is to add the two fractions together and not simplify just one. So you have to keep the x squared. In the second piece, I have x minus 4 times 7. That means I have to distribute the 7 to both of the values in the quantity. So 7 times x is 7x. 7 times negative 4 is negative 28. And then on the bottom I still have 7 times 2 is 14. And I still have that x squared. Now what I can do, make a nice fraction bar. On the bottom is my common denominator. And on the top I can combine like terms if I have them. So basically I'm going to take all of the top. See how the plus sign goes with the top? It does not go with the bottom. That's because the bottom just stays the common denominator. On the top I'm going to have whatever's on the top now with the plus sign. And I'm going to look for like terms. Well, this is x squared, this is x, and this is no x. So none of them can combine. So I just write 12x squared plus 7x minus 28. And that's my final answer. On the last problem, there's a couple things we need to keep in mind. We already saw up here where we said 7 has to be distributed to the x minus 4. That's true down on the bottom as well. One other thing that will be a gotcha if you don't pay attention is that the minus sign has to be distributed as well. Notice that it's minus that whole quantity. So keep in mind that you have to distribute the negative sign. So like before, I'm going to put this in a quantity, so I can't do anything to just one part of it. And then I'm going to look at, okay, what's the common denominator? Well, in this case, 5 and 3 are prime numbers, so let's just multiply them together. 5 times 3 is 15. So we need a 3 over here, top and bottom. And then on the other side, we need a 5. And what I'm going to do right now is I'm going to put the 5 in front so that I know I have to distribute it to the quantity. And I'm going to multiply by 5 down here as well. So it's 5 times that quantity and 5 times the 3. This time I have x cubed, and now I just have x to the first. So I need 2 more x's. So I need to multiply by x squared on bottom and top and rewrite it. So I have 3 times 9x is 27x over 3 times 5 is 15, and we still have the x cubed. And then notice something that happens. We're going to distribute the 5x to both values in quantity. I'm going to keep the minus sign right here for a minute. So I distribute 5x squared to x, and I get 5x cubed. 5x squared to negative 2. So I get negative 5 times 2 is 10, and then I have x squared. The denominator is 15x cubed. What we're going to talk about right now is the gotcha moment. If you don't pay attention to it, it's going to get you. It's going to get you the wrong signs. So I'm going to start out, I have 27x, and on the bottom I have 15x cubed, right? And remember, if I have subtraction on the top, it's on top of this fraction bar. So everything in there needs to go together as 1. That also means that if there's a negative sign here, a minus sign, that it gets distributed to the 5x cubed and the negative 10x squared. This is the part where most of you will mess up, is you'll give the negative to the 5x cubed, but you'll forget that that's a quantity. It's not just multiplied together, it is subtracted. So that negative sign doesn't just get attached to the 5, it gets attached to the negative 10 as well. So this sign needs to be distributed to both quantities on top. And if there were 3 on top, it'd go to all 3. And if there were 4 on top, it would go to all 4. You have to put your quantities with plus and minus on the top or on the bottom in parentheses. So this time we have negative times 5x cubed, and a negative times a negative is a positive, and that's the part you're going to mess up if you don't put them in parentheses. And I have 10x squared. What I would do is rewrite that, because I like standard form where the highest exponents go first. So I would take the negative 5x cubed and write it first. Then I would have the 10x squared, because it's x cubed, x squared. And it's a positive 27x because there's no sign in front of it, all over 15x cubed. Something that I notice on the top of this fraction is that this term has an x, this term has an x, and this term has an x. So we kind of have x's in every part of this fraction. So on the top, I have x in every term. So what if I took out the x from the top and rewrote it? So I have an x, and then I have negative 5x squared left. And I take out an x out of 10x squared, and I have plus 10x. And then I take a x out of 27x and get 27. And that's a whole quantity. So if I distribute it back out, I get back to the regular. And that's all over 15x cubed. And then since these are multiplied together, I can cancel out an x from the top and 1 from the bottom, and I get x squared instead. So my actual simplified answer would be negative 5x squared plus 10x plus 27 all over 15x squared.